Today we will be talking about row reduction and echelon forms. Let's first talk about what rules entail and encompass what an echelon form looks like. All non-zero rows are above any row with zeros, so all the zeros should be at the very bottom. Any leading entry of each row is in the column to the right of the leading entry above it. So like we've mentioned earlier in previous videos, that our leading entries should kind of come in a diagonal. All entries in a column below a leading entry are zeros. So right here, we'll just have zeros underneath them. So that is what echelon form looks like. So let's put in some numbers and look at how it looks. So let's say you have a number right here, a number right here, a number right here, and you have zeros, zeros, zeros. These X's right here will be our leading rows, leading entries. And above them, you can have any number still. So this could still be a number, this could still be a number, and this could still be a number. This is what echelon form looks like. So just to put some numbers in here, let's say it's 5, 4, 3, 2, 1, 10, and these are zeros right here. Okay, row reduced echelon form is on top of echelon form, you have a really specific way you want this matrix to look. The leading entry of a row is 1. So it can't just be any number like we've seen in echelon form, it has to be 1. And each leading one is the only non-zero value in that entire row. So you would have like 1, 1, 1, and we know that there's zeros underneath it. But another thing that's popular in row reduced echelon form is that everything in these rows must be zeros. So it just looked like this. This is what row reduced echelon form looks like. A pivot column is a column with a leading 1 in the row reduced echelon form. So this is our favorite row reduced echelon form matrix. Well, this is a pivot column. This is also a pivot column, and this is also a pivot column because it has a leading 1. So a basic variable is any variable column with a pivot. So x1, x2, and x3 in this case are all basic variables. They have a pivot. But let's say you had another variable like x4. It doesn't have a pivot, which means in this case, x4 is a free variable. This is a theorem that's really important. A system is only consistent, which means that it has at least one solution. If it does not have a row of zeros augmented with a number. So what it's trying to say is, let's say you have a row of zeros augmented with any number. So I'm just going to put number right here. This would mean that the system is inconsistent. We've talked about this prior in different videos, but let me just revisit why. Remember that this could also be written as 0x1 plus 0x2 plus 0x3 is equal to any number, let's say 10, which kind of simplifies to 0 equals 10, which is completely wrong, which means that this does not have a solution. So remember, a system is only consistent if it does not have a row of zeros augmented with a number. This would mean that it is inconsistent. Let's take a look at an example. We want to find the general solution of this augmented matrix. Some things to note right here is that this is already in echelon form, which is great. We just need to convert this from echelon form to row reduced echelon form, which just means we need to apply a couple of row reductions. Let's see what we can get. If we set row 1 to equal row 1 plus -2 times row 2, the matrix we will end up with looks like this. Now we want to write all of our answers in terms of our free and basic variables. So we want to go row by row or equation by equation and simplify what the equations look like now. So x1 plus 7x3 is equal to -9. x2 minus 6x3 minus 3x4 is equal to 2. And x5 is equal to 0. So we need to just rewrite everything in terms of our variables. So right here, we know that x1, x2, and x5 all are pivot variables, which means that they are basic variables. Versus x3 and x4 here, they are free variables. So let's rewrite everything in terms of our basic variables. So x1 is equal to negative 7x3 minus 9. x2 is equal to 6x3 plus 3x4 plus 2. x3 and 4 are free variables. And x5 0. So this is our answer.